Hello, this video is all about standard index form and basically what that is. This example that I've put up here is standard index form, in particular this bit. So it says 6.3 times by 10 to the power of 8. Now for a number to be in standard index form it needs to look like this, but there are a couple of rules. Firstly, this first part here, this number, this 6.3, it needs to be a number between 1 and 10 for it to be technically in standard index form. And secondly, this bit here needs to be a power of 10, so this says times 10 to the power of 8, so that could be times 10 to the power of something else, but it still needs to be a power of 10. Okay, so basically to be able to use standard index form, which is like a shorthand for writing very large and very small numbers, i.e. and a more convenient way of doing that, we need to know how to write powers of 10 in using those powers or indexes or indices. Okay, so obviously 10 is just 10 to the power of 1. 100 is 10 to the power of 2. 1000 is 10 to the power of 3, and so on and so forth. We could continue with that. So if I wanted to write, I don't know, say something like 3000, I know this is 3 times by 1000, which would be 3 times 10 to the power of 3, because 1000 is 10 to the power of 3. So this is basically how it works. But there are some useful ways of being able to convert between normal numbers, which is this bit, and standard index form, which is this bit. So with that being said, we'll look at an example and how we can calculate or work out how we do this relatively quickly. So if we start with an example of let's say 36,000. Okay, well, at the moment the decimal point is right at the end. We can't see the decimal point, therefore it's right at the end. We just assume that it's right at the end there. In order to get this first number, this where it was 6.3, in order to get that first number we need the decimal point to be in such a place that the number that we end up with is between 1 and 10. So if I were to say put the decimal point excuse me, here, then that is 3600, 3600.0, which is clearly not between 1 and 10. So actually to do that we'd need to put it here, which is 3.6. So we know that the first number would be 3.6, but in order to calculate what the power of 10 part would be, we need to find out how many decimal place movements there are. So for instance, we go, this one is 1 space, then 2 spaces, 3 spaces, then 4 spaces. And because this is a large number, we'll get to small numbers in a minute, but this is a large number, so it's times by 10 to the power of 1, 2, 3, 4 decimal place movement, so that makes it 4. So hopefully that makes a bit of sense. We can do another example, which would be something like 42 million, which is a very long number. And this is where we get to see why this standard index format is actually useful, because we can start with this and say, right, I want to convert it. So where's the decimal point? At the moment is here. Where do we need it? Well, we need it to be in between the 4 and the 2, so it's 4.2. So how many movements are there? Well, 1, 2, 3, 4, 5, 6, 7. So that's times 10 to the power of 7. And you can see that this is a bit quicker to write than 4.2 million each time. So that's how we convert from large numbers to standard index form numbers. But what about if we wanted to do it the other way around? Well, let's take an example, 3.47 times by 10 to the power of 5. What does this mean? Well, times 10 to the power of 5 is actually 100,000. You don't necessarily need to know that, but so we've got 3.47 times by 100,000, which we could do it like that, but there is an easier way by dealing with these decimal points, and this in particular this power on the 10. So we've got 3.47 times 10 to the power of 5, so I'm going to move the decimal point forwards by 5 spaces. There we go, 5. So I'm moving it 5 spaces. Any loops that haven't got numbers in them, I'm going to put zeros to fill them up. So then what we get is the decimal point right at the end. So we have 347,000 or 347,000. So that hopefully shows how easy it can be. We'll do one more example. In fact, let's do this example up here. So 6.3 times 10 to the power of 8. So in order to convert this, we start with the 6.3. We're going to move the decimal place 8 times, because that's the power, in the right hand direction, i.e. making the number bigger. So what's that? 5, 6, 7, 8. Decimal point goes here. Fill in the loops with zeros. And there we have it. 630 million. So hopefully that makes a bit of sense. So what we've been doing so far is looking at large numbers, the millions, the thousands, the hundreds of thousands, and so on and so forth. But sometimes we end up with small numbers, and this might be something along the lines of 0.006, but it still works in the same way. We still need to have standard index form in this particular format with the same rules. So the first number needs between 1 and 10. So if we look at our example here, 0.006, where do I need to put the decimal point so that the first number here would be between 1 and 10? Well, hopefully you realise that it needs to go here, because that's 6.0, or just 6. So that's fine. And then we've got times 10 and the power. Now this is where it slightly changes, because we've still got a jump of 1, 2, 3 times, so we still count the jumps, but in this case, because it's a small number and we're actually moving the decimal place forward to convert to standard form, we need to put a minus or negative number, so that would be -3. So 3 jumps but negative because it's a small number. Okay, so let's have a look at another example. We'll do the other way around this time. So 5.2 times 10 to the power -4. So a standard index form number, and what we want to do is convert it into a normal number. So we start with a 5.2. In fact, hold on. We'll start with a 5.2, and we're going to move it 4 spaces. But we're not moving it to the right, we're moving it to the left, i.e. where the number is getting smaller. So we're going to move it 4 times, 1, 2, 3, 4, decimal point goes here, fill in the zeros, same thing again, and then we've got 0.00052, or 0.00052. And that is small numbers, or in standard index form, converting to and from. So hopefully that makes a bit of sense. Rightio, so the last thing that we need to be able to do using standard index form is to be able to do some calculations. So calculations with standard index form. So if we wanted to add or subtract with it, best thing to do is for me to give you an example. 3.3 times 10 to the power 3. And what I'd like to do is add this to 1.5 times 10 to the power of 2. Now, adding standard form is not something that can be done easily whilst the numbers are in standard index form. So we need to convert them. So to convert them into normal numbers first of all. So we've already discussed how to do this, but I'll quickly show you. 3.3, move the decimal place 3 spaces because it's positive. So that goes here, so that's therefore 3,300. And then we're adding 1.5 times 10 to the power 2, which is 2, so that's 150. So 3,300 plus 150, so 3,450, and that is the answer. If we really wanted to, we could convert this back to standard index form by saying I need the whole number to be between 1 and 10. So decimal point needs to go here to make 3.45. That's a jump of 3 times. So that's times 10 to the power of 3. So there we go, that's how to add. Subtracting is exactly the same, we just convert into normal form and then do the subtraction. Okay, what about if we wanted to multiply using standard index form? So here we go, here's the example, 2.3 times by 10 to the power of 3, multiplying this by 5.2 times by 10 to the power of 4. Well, with this, it can actually be done just using standard index form. We don't need to convert into normal form and do a whole multiplication of very large numbers. That will take a long time. So what we're going to do is separate what we're going to do. So 2.3, and we're going to multiply this by 5.2. So 2.3 times by 5.2, and this makes 11.96. You can check that on your calculators if you want. We're not looking at the long multiplication form at the moment, but that does equal 11.96. The next part that we're going to do is 10 to the power 3 times by 10 to the power 4. Now, if you're wondering how we do that, this is just indices. The base number is 10 in both. We're multiplying, so we add those powers together. So that makes 10 to the power 7. So then what we got here is a combination of this and this to make 11.96 times by 10 to the power of 7. However, those of you that may have realized already, this number here is not in the guidelines for a standard index form. This is not between 1 and 10. So this number needs to be reduced by moving that decimal point. So we should have 1.196. So we've made that bit smaller. So we just use the rules of standard index form. When you're making a number smaller, you add on to the power. So there we go. Just add 1 onto the power because we've moved the decimal point 1 space backwards. So that's the division, that's the multiplication. The next thing we're going to do is have a look at division, and you'll be pleased to know it works very similar to multiplication. So here's an example, 9.1 times by 10 to the power 5, and we're dividing that by 2.5 times 10 to the power of minus 2. So once again, we're going to split it up into the number bits first. 9.1 divided by 2.5. Again, we're not doing long division here, so check this on your calculator. That makes 3.64. And then the last bit, 10 to the power 5 divided by 10 to the power of minus 2. Now, rules of indices, same base number here. So we're going to take the powers away. You have to be careful with this one though, because this makes 5 take away minus 2, because the power is minus 2 already. So we're taking away minus 2, which makes a plus. So that would actually be 10 to the power of 7. Then we combine the two bits here together. 3.64 times 10 power of 7. Double check this bit. That is between 1 and 10. So this is our answer. And that is the end of standard index form. Please feel free to have a look on the library for some example questions. Thank you. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done. That's good.